Hello everyone, my name is Juan Sebastián Salcedo-Gallo, and I'm here to present you our paper on proactive detractor detection framework based on message-wise sentiment analysis over customer support interactions. We're presenting this at NeurIPS 2022 at the LatinX in AI workshop. Now, picture yourself as a user of a financial service, and then you have an issue. Then you try to contact customer support center, and you talk to an agent trying to solve that particular issue that you might have. Then 3 months later, you find this question via WhatsApp or via email, namely, how likely would you be to recommend this to your friends or family? Now, depending on your response, which generally goes from 0 to 10, that is a clearly good indicator of customer experience across organizations. And of course, your response will depend on the overall customer experience that you particularly have. And generally, these NPS scores are measured at a frequency ranging from monthly to an annual basis. Now, consider that very same question, but then you predicted 3 months earlier that a single customer is not having great time with the app, and all the information you've got are the chats of that particular user with customer support. Now, if you use that information to send incentives or trying to proactively contact the user to try to solve the issue that he or she might be having, you therefore hope that in the next NPS survey, the user will give you a higher rate. That is, of course, not only good for the user, because that obviously improves the customer experience as a whole, but this is also important for organizations that, as this NPS score is a very important performance metric across organizations. Now, this leads us to our research question, which will be, can we use that information stored in our chats interactions to predict the recommendation decision in the future for our users? Now, consider that you're a company and you're trying to predict the recommendation decision of your users, and you perform some surveys which have some test reviews and specific service ratings with information that is surveyed, retrieved, and processed at the same time. Of course, that does not leave any room for proactive intervention of singular users. And given the massive outreach of commercial messaging platforms such as WhatsApp, or even the use of our super app Rappi, which have presence in 9 countries, and financial vertical RappiPay, which have presence in 5 countries in Latin America, we have lots of chats. And for the financial vertical will be via the personal bankers, which are there for solving any issues that the users might have with the credit card. Now, there is also a fundamental difference between reviews and chats, and that is a very strong motivation for a project, because reviews and service ratings are statical, whereas chats by definition are essentially dynamical, which of course give you more freedom to use that in classification tasks. And if you will, it'll be like comparing images to videos. And of course, the video can give you a clearer picture of any particular situation depending on the context. Now, imagine that you're a user and you're trying to activate your physical card, but you're having some issues and you contact customer support. Then you start the conversation rather neutral with a hello, which there's nothing positive nor negative about a hello unless it comes from your crush, right? Then as the issue is being exposed, you then swing to rather negative sentiments to then end up rather positive, as the issue might have been eventually solved. And if you plot that, you obtain a line like this, as we have empirically validated in our experience, right? Now, if we formalize that, we can consider a conversation as a vector where each element corresponds to each message on the conversation, and then we obtain the static sentiment for each message and the probability of that particular sentiment using bidirectional encoder representation from transformers, or BERT for short. We then consider a continuous message-wise sentiment as the sum of that static sentiment per message plus the probability of that sentiment per message. And we therefore apply a corresponding moving average to further smooth distribution and obtain a more smooth line with the corresponding expression that you see on the screen. Now, if we once we obtain that line, we obtain several handcrafted features because we as well wanted to obtain some interpretable results out of the analysis. And we, of course, obtain a slope and intercept of simple linear regression fit to MA, some descriptive statistics, so on and so forth. And we also performed a concavity analysis as well as the coefficient of variance, as we wanted to classify or characterize the overall shape conversation, whereas it was like convex-like or concave-like. Now we defined our experiments. Our baseline will consist of a static sentiment estimation on the concatenation of the messages, and we're trying to mimic a review-like approach. We also consider a line-wise sentiment analysis, considering and ignoring passive users, where the passive users are those who rate the service at 7 or 8. We use XGBoost as our model with random undersampling over the trained set, random search hyperparameter tuning, and we had a number of samples belonging to each class corresponding to roughly 10,000, 3,000, and 2,000 for promoters, detractors, and passives correspondingly. Now, we can just take a look at the notation over here, and here are the results. If we take a look at our baseline model, we can see from the AUC that our baseline approach is only marginally doing better than a random guesser, but then it is comparable in performance to other approaches, even if those consider specific service ratings as predictors. And of course, these other approaches does not leave any room for proactive intervention. Now, if we consider our line-wise approach, we can see that line-wise sentiment analysis is substantially superior in terms of predicted power. And of course, we have performance gains of about 10 to 14% versus a review-based sentiment classification approach in any case, even considering or ignoring passive users. And we can see also that our line-wise sentiment analysis helps them better separate between promoters and non-promoters, which can be further validated by by looking at the scorecard, where the score represents the probability of a user to be a promoter. And we can see that indeed the line-wise sentiment analysis, or the model trained with these features, is capable of separate between members of each class on the test set. Now, if we take a look at our interpretable results over our handcrafted features, we can see that interpretable results are in excellent agreement with human intuition. And if you take a look, for instance, at the slopes, you can see that the higher the slope, the higher the recommendation decision, and that is very relevant because a high slope means low customer frustrations, as the issues might have been eventually solved, right? Now, for future work, we think that it will be very interesting, for instance, to get an RNN that can learn the temporal relations in this sentiment evolution distributions and get a real-time evaluation or even suggestions to customer support agents. We have some handcrafted features, but wouldn't it be nice if a recurrent model could actually learn these representations? Now, the main takeaways is that it is possible to predict the recommendation decision of users based on chat-based data sources, and natural language processing techniques can be used not only to improve customer experience as a whole, but also the product itself. And of course, NLP is nowadays a key player in the industry domain. And it is very nice indeed to unveil inherent characteristics hidden in the dynamic nature of our conversations to then perform classification tasks at hand. And of course, more research on the subject is strongly encouraged. You're very welcome to take a look at our paper by scanning this QR code. And I would like to thank LatinX in AI Workshop, NeurIPS, Rappi, the company I work for, and of course to all of you that are watching this.